Hey, fourth grade, you're hearing from me 2 times in one day, but for good reason, because I want to have a quicker lesson on how to round. The reason I'm doing this is because everything the teachers are sending home for you requires a little bit of rounding to estimate. Whether it's multiplication, division, addition, or subtraction, you better be estimating in order to check yourself a little bit. So I'm going to first show you this picture I drew, and then talk about the 4 steps to rounding, and then I'll give you an example as well. The picture I drew is of a beautiful sunny day, and the digits 0 through 9 are outside playing. And as I like to say, 0 through 4 are enjoying their day. And 5 through 9 are flying away. Kind of rhymes, so I like to say that back to back. 0 through 4 enjoy their day. 5 through 9 fly away. Okay, now that I know that, that'll help me on later on as I keep going. So, let's give you an example problem as I list the steps. I'm going to round the number 824 to the nearest 10. The first step always is underlining the place value that you're looking for, the nearest 10. So I'm going to write down underline place value. If I was looking for the 100, the nearest 100, I would underline the 100. If I was looking for the nearest million, I would underline the million place value. You should know your place values by now. This is the ones, this is the tens, this is the hundreds. So if I'm looking for the nearest 10, I underline the tens. Step 2 is circling the friend on the right. So after I underline the place value, the digit that is immediately on the right will be circled. So I'll say circle, arrow pointing to the right. Circle the friend to the right. Now this picture comes into play. The circled friend always decides what the 2 numbers are going to do that day. They might enjoy their day, or they might fly away. 4 will tell the 2 what to do. The circle will tell the underlined place value what it's going to do. For example, I notice that 4 enjoys its day on the ground, stays the same or stays on its level. So the 2 will stay the same. It's enjoying its day. It's not going to bump up and become a 3. It's just going to stay on the ground level. So in this case, you have to ask yourself, enjoy or fly? Does 4 enjoy its day or fly away? 4 enjoys its day. It's on the ground with 0 through 4. So 2 will also just enjoy its day because the circle tells the underline what to do. So everything to the left of the underline stays the same. Everything to the right becomes a 0, which is actually step 4. So 2 enjoys its day, stays the same, and everything to the right becomes a 0. Everything to the right of the underline becomes a 0. It doesn't matter how many place values are after it. I'll do another example using my 4 steps. Better make that clear. The underlined digit doesn't always become a 0, but it stays the same or flies away, and everything after it becomes a 0. I'm going to do another quick problem. How about 976? If I was once again rounding to the nearest 10, step 1, I underline my place value I'm looking for, which in this case is a 7. Step 2, I circle the friend on the right, which here's the underline. I go 1 to the right, and it's a 6. Step 3, I have to ask myself, do I enjoy my day or fly away? I look to the circled friend. The circled friend decides, enjoy the day or fly away. Whatever the circled friend says, the underlined friend's going to do. 6 on my chart is flying away, so it wants to fly away. It tells the 7 to go up or fly away. The 7, the underlined digit, will fly away and goes up 1, becomes an 8. Everything to the left stays the same. Everything to the right of the underline, step 4, becomes a 0. And another way to think about this is I had two options. If I was rounding this original number to the nearest 10, it was either going to stay the same, 7 was going to stay a 7 and go to 970, or the 7 was going to fly away and become an 8 and go to 980. And if you think about it, if you get halfway between the numbers, you round up to the 980. And if you're lower than halfway, you round back down to the 970. That's where this fly away or enjoy your day comes from. I'll do another couple examples because I really want you to see the four-step process. It works with even larger numbers too. For example, 15,381. Okay, and let's just say that we're not rounding to the nearest 10 anymore. Let's bump it up. We're rounding to the nearest, how about 1,000? Okay, same thing. My four steps will help you be successful. Underline the place value that you're looking for. I'm rounding to the nearest 1,000, so that's the one I'll underline. By now you should know that this is the thousands place value, the 5. Circle the friend to the right. Done. Now I have to ask myself, does the circled friend enjoy its day or fly away? I look at my chart. It's less than halfway up, so I have to say it's going to enjoy its day. The circled friend told the 5 to enjoy its day as well, because the circled friend always decides what these two friends are going to do. Now, if the 5 enjoys its day, stays the same, step 4, everything to the right of the underline becomes a 0. 15,000 is the closest thousand to 15,381. If you think about the options again, I could have either gone to 15,000 or it would have bumped up to 16,000. Would have been the 1,000 that's above. So the 3 told me that it was closer to 15,000 than it was to 16,000. That's a quicker way of kind of thinking about that. There's one last example I want to send your way when things get a little bit trickier. I'll like this just for now, just keep it a little bit simpler. Here's the number 8,972. If I was going to round that to the nearest 1,000, or excuse me, nearest 100, let's take a look at what I would do. Nearest 100, underline the place value that I am looking for. The nearest 100, everyone knows that this is the hundreds place value. Circle the friend to the right, easy enough. Maybe you're getting a little quicker at this and you can say enjoy your day or fly away. Does 7 tell 9 to stay the same or bump up? 7 tells it to bump up, but I can't just make the 9 into a 10 because 81,000? That doesn't make any sense. So when a 7 tells a 9 to bump up, or maybe it's an 8, tells the 9 to bump up, and this becomes a 10, you have to turn that 9 into a 0. The underlying place value becomes a 0. And you carry the 1 over to the next place value. So the 8 will actually become a 9. And everything, once again, to the right of the underline becomes a 0. So it's kind of funny in that number, 8,972, if I erased all my work that I just did. The nearest 100 is actually 9,000. And it's also the nearest 1,000. It just so happened that they round into the same thing. Whenever that happens where it bumps over, maybe it could even bump over twice, and you got to be prepared for that too. So, for example, let's say I was rounding to the nearest 100, and I had 9,972. I underline the hundreds place value. 7 trails the 9 to become a 10. I carry it over to the next one. This became a 0. And this 9 becomes a 10. Well, then that needs to become a 0 too. And I carry the next one over to the next place value. and this is kind of a crazy situation, so I hope you're staying with me, but the nearest 100 was also the nearest 1,000, and it was also the nearest 10,000. So 10,000 would be my nearest 100, because I can't have a 10 in a single digit place value. So I have to keep carrying the 1 until it works out. I hope this, I know that last problem was kind of difficult. If you're a little confused on that, that's okay, as long as you got the major understanding of the 4 steps to rounding. This is something you can easily try or do examples of at home. If you want to get some practice, you can make up some problems on your own. The other thing with this too is pretty soon we're going to work on rounding decimals to the nearest 10th or the nearest 100th. And we're going to use the same exact process. So I hope you memorize this process. So by the time we get to the rounding decimals, you'll have this down for sure. Okay, thanks guys. We'll talk to you later.